Good morning, everyone. My name is Lê Tuấn Hùng, and I'm thrilled to share a presentation on understanding cryptography, hashing, and encryption. In today's digital world, security is a major concern. Whether it's protecting our personal data, securing online transactions, or maintaining the integrity of our system, cryptography plays a central role. Over the next 6 minutes, I will guide you through the key concept of cryptography, specifically focusing on hashing and encryption through techniques that safeguard our digital communication. So, what is cryptography? Cryptography is the science of securing communication and information using mathematical techniques. It's designed to address four critical principles. First is confidentiality, keeping data private and accessible only to intended users. Second is integrity, ensuring data is not altered during storage or transfer. Third is authentication, confirming the identity of user or system. And fourth, non-repudiation, preventing denial of action or commitment. Think of cryptography as the invisible shield that protects sensitive information like your bank details, personal conversation, and even government communication. This field relies on two core techniques, hashing and encryption, which I will explain in next detail. To understand cryptography better, let's compare hashing and encryption. Hashing is a process that converts input data into a unique fixed-length string or character. This is one way, meaning it cannot be reversed to retrieve the original data. For instance, when you set a password online, it hashes the value is stored rather than the actual password, ensuring security even if the database is breached. Encryption, on the other hand, transforms plain text into unreadable ciphertext using a key. This is reversible, meaning the original text can be retrieved by decrypting the ciphertext with the appropriate key. For example, when you send a message over WhatsApp, it is encrypted so that only intended recipient can read it. Both methods serve different purposes in securing our data. Now, let's explore hashing in more detail. Hashing is a critical tool in cryptography for securing data. Here is some key property of hashing. First is deterministic. The same input always produces the same hash. Second is very fast to compute. It is efficient even for large amount of data. And this is irreversible. One hash, you can retrieve the original input. And fourth, collision resistant. Two different inputs cannot produce the same hash. Hashing is commonly used in password storage. Websites store the hash of your password, not the actual password. Even if a hacker gains access to the database, they will not be able to see your real password. And integrity check. When you download a file, it has ensured it hasn't been modified during the transfer. For example, as you can see here, the checksum of this file to ensure its authenticity. Now, let's see a hash algorithm in action. This is an online hashing tool that uses the algorithm SHA-256. As you can see, if I input a string in here, it will generate for me a hash. And we copy it here so we can compare later. As you remember, only an input can only generate a hash. So no matter how hard I try, it will not generate for me a different hash. Unless I change the input. As you can see, the hash is now different with the first hash. And if you want the first hash again, you have to input the same input as the first one. As you can see here, when I input the same string, I get the same hash. That is how hashing algorithm works. That is hashing. So now, what is encryption? Encryption ensures data confidentiality by converting plain text into ciphertext using a key. There are two types of encryption. First one is symmetric encryption. This is a single shared key for both encryption and decryption. It is fast and efficient, making it ideal for encrypting files, securing Wi-Fi network, or sending messages. However, securely exchange the shared key between the sender and the recipient can be a challenge. Let me show you how it works. This is an online tool for encryption. There's an online encryption tool that uses the AES symmetric encryption algorithm. Now we will try to encrypt this message using the key, using a predefined key. I press encrypt. As you can see, my message is now encrypted. And now I will try to decrypt the message using the same key. As you can see, the message is easily decrypted. But if I doesn't have the key, I cannot decrypt it. As you can see, it said that the key is not correct. That's how symmetric. The challenge of the first kind of encryption takes us to the second kind of encryption, asymmetric encryption. This is a pair of keys, a public key and a private key. The public key is used to encrypt the data, and the private key is used to decrypt the data. Although slower, this method is crucial for applications like digital signature, secure web browsing, and authentication. Here's a practical example. When you visit a secure website, your browser and the server exchange a public key to encrypt the data. Only the private key, held securely by the server, can decrypt this data. Let me show you in action. Now this is an online tool that uses RSA asymmetric encryption algorithm. To use it, first you must generate a key pair, which is a public key and a private key. As you remember, public key is for encryption and private key is for decryption. You cannot encrypt using the private key, and you cannot decrypt using the public key. Now I will try to input a message in here and try to encrypt it. Here's our encrypted message, and now I will try to decrypt it using the private key. As you can see, our message is decrypted, but if I use a public key for it, I cannot decrypt it here, but we can easily decrypt it using a private key. Both symmetric and asymmetric encryption are essential tools. They are often work together in securing digital communication. Each method has its strength, and they are often used together through a method called hybrid encryption, where symmetric encryption, which is faster and can encrypt a large amount of data, is used to encrypt and decrypt the plain text. But the symmetric key will be securely exchanged using the asymmetric encryption method. To conclude, cryptography is the backbone of modern digital security. Hashing ensures data integrity, verifying that data hasn't been tampered with. Meanwhile, encryption ensures data confidentiality, protect sensitive information during transmission or storage. Together, the technique enables secure communication in everything from emails to online banking, protecting individuals, business, and government. Thank you for attention. If you have any questions, I will be happy to answer them.